All right, so this is a number talk missing factor. It says solve each equation mentally. So I'm just going to do a couple of these with you guys. And here's what I'm going to look at. X is something. I don't know what X is. And it's going to, whatever X is times 16, it's going to be 176. So there's lots of different ways you can do these mental math. My first thought was, well, okay, what's 10 times 16 equal? 160. And you know what? That's really close to 176. And then I know in my head, gosh, 160 plus 16, that is going to equal 176. And so that's how I would do it in my head. So it's not 10, but 11. So I'm just going to put an 11 right there. Maybe put a square around it or a circle or something. That's one way, and there's lots of different ways again that you could do these as you think about them. So that's the first one. Then how about 16x equals 8? Well, again, I don't know what x is, but I do know this. Anytime you multiply a number by something and it's smaller, Miss Carol, than the original, I know that variable, and x is a variable, is going to be less than 1. Whatever it is, it has to be less than 1. Otherwise, the answer would be bigger than 16. Of course, if it was 1, it would be 16. So I know it's less than 1. Well, I think most of you can recognize the relationship between 8 and 16. 8 is half of 16. And so half of 16, well, I'm going to have to multiply it by half. So 16 times 0.5, I could put 0.5, or maybe I'd just put 1/2. Either way, my answer would be 8. So I'll just put a little square around that. Now, there's something else I'm going to have you guys do, and I'll just mention it really quick in the video. On the Google Classroom, there's an assignment, a new assignment I put up, and it's called an Edpuzzle. Edpuzzle. All right, and you'll go to edpuzzle.com. Didn't write that very well, .com. And actually, if you just click on it, it'll automatically log you in. I've got 3 classes on Edpuzzle. I've got a 6th grade, 7th grade, and an 8th grade. And very quickly, how the Edpuzzle works is that you're watching a video, and some of the stuff she talks about is what I've talked about. And instead of watching the whole video and then answering a bunch of questions at the end, what's nice about Edpuzzle is that you'll watch it for 2 or 3 minutes, and then it'll stop and ask you a question about what they were just talking about. Now, I've done my own Edpuzzles, but they're very time-consuming to create, so I often use others, people that have already created an Edpuzzle for whatever math we're going over. So just wanted to let you guys know about that. All right, let's see here. Let's look at page 42. It says, are you ready for more? Triangle B is a scale copy of triangle A with a scale factor of 1/2. It says, how many times bigger are the side lengths of B when compared with A? Well, actually, if I'm reading this correctly, triangle B is a scale copy of A. So I'm just going to draw a triangle here. Okay, and I'll call this one A. And it says B is a scale copy of A with a scale factor of 1/2. So is A, the scale factor is 1/2. Is B going to be bigger than A or smaller than A? Smaller. So I'll draw a smaller triangle, and I'll call that B. All right. Now, if the scale factor is 1/2, how many times bigger? I would have said or smaller. Are the side lengths of triangle B when compared to A? Well, there's lots of ways you could phrase this. They are half the size. You can just copy what I wrote or come up with your own words. Okay, they're half the size of A. Maybe I should be specific of triangle A. Okay. So you can answer 2 and 3. And then let's jump over to page 43 here. It says missing figure, factor, or copy. It says, what is a scale factor from the original triangle to its copy? Explain or show your reasoning. So let's turn the page. What are they talking about here? Here's the original. Quite a bit larger than the copy. And so then it asks you, what is the scale factor from the original triangle to its copy? Well, gosh, what would be one of the easiest ways to compare the two? Well, they don't give us any specific size as far as numbers on the sides, but you can see that on this side here, this is what I'm looking at, 1, 2, 3, 4, 5. And how many on this side right here? Is just 1, okay? So it's 5 to 1. Or you could say it's got a scale of, it's 1/5 of the original. All right? So that one's kind of done for you. I think you can answer the rest on 44 and then 45. You can see the top of page 45. And I've talked to you many times, lesson summary. There's no questions, but they explain what the lesson is about. And so there's the bottom of page 45 and the top of page 46. There's a nice lesson summary if you're not too sure. Now, as I explained earlier, I don't want you to do this in your book because I have a handout I'm going to give you. So do the handout, not what's in your book. If you do what's in your book, then you're just going to have to copy it over onto the handout. But I'll do the handout when I'm done going over the rest of the lesson here. And I'm almost done. All right, so I'm looking at the top of page 48. It says, what's the scale factor from S to L? And again, you can just pick a couple sides that might be easy to compare. I'm looking at the base. There's 2 there, and there's 1, 2, 3, 4 there. I'll let you go from there. And then 5 here at the top of page 49, it says select all the ratios that are equivalent to the ratio of 12 to 3. Now, we talked about ratios briefly last week, but let's just do it again. So this is a ratio, 4 to 5. What would be an equivalent ratio? Let me pull a stick here for some points. An equivalent ratio. Miss Soldati, can you give me an equivalent ratio of 4 to 5?
8 to 10.
Yeah, 8 to 10. All she did is double it. Nicely done. Put up 10 points. Let's see here. Mr. Gwynn, you had your hand up a minute ago. Can you think of another ratio that would be equivalent to 4 to 5? 12 to 15 would be another ratio. Nicely done. Put up 10 points. Now, ratios don't have to be larger. Question?
No.
Yet another one? Go ahead. What is it?
16 to 20.
16 to 20 is another ratio. Put up 10 points. Now, what I was going to point out is that ratios don't have to be larger. They can be smaller. So what if I cut 4 in half? What would that be? 2. What's 5 in half? 2.5 or 2.5, either one. That's also an equivalent ratio, okay? So equivalent ratios can go either way. All right, questions about any of these, you guys? Yeah.
Well, I figured out another ratio.
All right, what is it?
1 and 1. Okay, so 1 and 1/4.
1 and 1/4 is also an equivalent ratio. Nicely done. Now, another way you could do an equivalent ratio, since we're still on it, how about if I just multiplied each one by 1,000? That would be 4,000 to 5,000. A lot of whatever it is, exactly. Okay. All right, so I'm going to end the video here. Don't forget, you have an assignment. on the Google Classroom. Now, I'll end the video here, but I'll talk about that more in just a moment.